My name's Sean Kinney. I'm the managing editor for RCR Wireless News and Enterprise IoT Insights. And both teams spend a lot of time covering the in-building wireless space. It's fast moving and it's really seeing a great deal of investment and innovation at the moment. So today we're going to learn a little bit more about some of those market trends from Marc Bouvrette, who's the Gap Wireless president. So Marc, thanks a lot for joining us to have this discussion today.
Oh, thanks a lot, Sean. Appreciate the opportunity.
So before we really get down into it, can you tell us a little bit about Gap Wireless, about the company? And I know you guys have a very broad range of products. Maybe give us a little bit of an overview of the solutions that you guys have.
Yeah, absolutely. We're celebrating our 10th year anniversary this year. So we started in 2007. Like you mentioned, our products are very broad. However, our area of focus, if you want, is relatively narrow. So we're very focused on the wireless network operators, whether that be commercial, so 3G, 4G operators, or public safety, mining, essentially any types of wireless networks, whether they're fixed or mobile. So we provide the infrastructure. When we started, we were very focused on everything that was very RF-oriented, conditioning, amplifiers, filters. Over the years, we've expanded on that product set. So we get into a lot of fiber, copper cable now, as well as we've launched a UAV division for doing cell tower inspections. So we've really broadened our reach in the wireless industry to be able to provide all-encompassing solutions to our customers.
Yeah, you mentioned UAVs in there, and that's something that I think we're going to talk a little bit more about later, just because what a fascinating set of applications those bring to the table for telecom. But first, let's talk a little bit about in-building wireless, particularly DAS and small cells. So Marc, based on the interactions that Gap has with their customers, what kind of trends are you seeing in terms of in-building systems for spaces like hospitals, hotels, transit hubs, that type of thing?
Yeah, so we're definitely seeing more and more in-building, whether it's underground or inside the buildings, but basically areas that can't be effectively covered by the macro network. A lot of investments. Many of our customers are actually investing more in the in-building underground type deployments than in the macro. So over the years, the initial focus of wireless networks was really about coverage, being able to say that you're covering as much of a country as possible. But now we're really seeing a shift to capacity, which in building, where people are using their phones not necessarily to talk on them, but a lot more for data, for connectivity. So it's important to have good capacity inside buildings. And we've really seen in the past few years a lot of emphasis being put on venues such as stadiums, arenas, shopping malls. So areas that we call more public, where you don't necessarily know that your customers are going to be there. However, there's so many people that are going to be in that venue. If you have 30, 40% of the market share, you know the customers are going to be there. Today, we're seeing a shift more towards, since a lot of those venues are now done, we're seeing a shift towards going after more enterprise-like, residential. You mentioned hospitals. That's another one that we're seeing a lot of investments in. So not as high density of customers per square feet, but still very important to the carriers. And that brings a lot of challenges. They're very different types of deployments.
Yeah, I really think we hear the term a lot, middle prize, to kind of refer to these venues that are big enough to drive a large amount of investment, but maybe not big enough to be one of these marquee venues like a stadium, like a big transit hub, like an airport, where you're definitely going to get investment from the carriers. So what are you seeing in terms of the business side of that as the carrier spend kind of decreases and it's becoming more important for the enterprise to actually invest in connectivity?
Right. So a lot of the customers that we're working with are kind of waiting for the next technology shift or paradigm shift in technology when it comes to DAS. So we're hearing a lot, obviously, about small cells. The issue with small cells today is they're still, although a lot of manufacturers are talking about multi-operator, multi-carrier, multi-frequency small cells, I'd say that's not really widespread yet. There's still some challenges in delivering those products. So most of the small cell, or I'll call them access point Wi-Fi type deployments, about for 3G and 4G, are still very much a single operator. And those work well if you're lucky enough to be the operator that got exclusivity on the building, or it's just your network that you're trying to deploy. The issue is when you get into on the enterprise side, most of the customers, they're going to want to have all the carriers deployed and operating inside their building. So the traditional hybrid, it's not hybrid, but sorry, active DAS with coax cable is very expensive, and unless you have that density of people inside the building, it's very hard to justify the costs for it. So we're really seeing a shift towards these more copper cable UTP Cat5, Cat6 products. A few manufacturers that we're working with right now do have these neutral host type, so multi-operator, multi-frequency, multi-carrier products that are deployed like a Wi-Fi network. And the economics of those networks work much better for a middle price enterprise type of deployment.
Yeah, it really is an interesting dynamic there, because like you said, a full-blown DAS system it's very expensive, but some of the small cell products are very limiting in what you can do. And like you said, an enterprise, given what we know about bring your own device trends, you're probably going to want to support all four carriers unless it's a very unusual kind of circumstance. One thing I wanted to ask you about, and it's something that we've been hearing a lot about from our community, is this approach where for, say a 200,000 square foot office building, you use small cells to feed into an active DAS. So you kind of remove that expense of the baseband unit and everything that comes with that by putting in that small cell, but still get that coverage benefit of the DAS. Is that something that you guys have been seeing?
Yes, absolutely. So I think it's important to understand that a DAS system, so we're talking about active DAS. DAS means distributed antenna system. The DAS itself doesn't do anything for a signal source. You could put a repeater at the front of it. That's not very desirable for a host of reasons: capacity, noise in the macro. There's many reasons why it's not desirable. But you could do that. So you fall back to your source generally being a node B. So the node B has to come from the wireless carrier. No enterprise customer can just go knock on Nokia or Ericsson's door and buy a node B, and maybe they could, but I'm not sure they could do much with it anyways. So looking at small cells, which get categorized into multiple segments, if you're looking at like femtocells, for example, where carriers who provide the access to femtocells to their customer can go and buy it at a local retailer or distributor, plug it into his Ethernet connection back to whoever his provider, his ISP is, and that provides him now the signal source, which could feed into the DAS. And you can have multiple of those femtocells or small cells from each one of the carriers feeding into your DAS. So yes, we absolutely see that. Definitely on the enterprise side, that's one application for it. But I'd say even certain carriers today, where they don't have the capacity needs of a full node B, are considering using small cells. So a microcell, which is kind of halfway between a femtocell and a full-blown node B or eNode B, they're using those small cells to feed the DASs. And the beauty of the active DAS is it's generally quite technology agnostic, not necessarily frequency agnostic, so you have to have the right frequency support in your amplifiers. But once you do have that, then it's very easy if you need to increase your capacity from a microcell to a full-blown eNode B. It's an overnight upgrade, really, where you're visiting the telco room where the head end is, and overnight, as I mentioned, all of your different telco rooms and every single floor that has the active DAS deployed will be turned on with that new capacity.
Yeah, and that's still kind of it's not brand new, but that hybrid approach is not something that you see a ton of. But as that kind of gains traction and gains mind share, would you expect to see that as a pretty attractive option for enterprises that are looking to self-fund connectivity?
Absolutely. I think that would be the case. And the reason why I think we haven't seen it so much is we've been hearing about small cells for I'd say probably the past 5 years. And really, we're only starting to see some massive deployments in the past 12 to 18 months. So the concept of small cells is not new. The availability of them is a little bit more recent, however. So I think that there's been a lot of augmented capacity outdoors, so like festival areas, again, areas where you have large congregations of people coming together and where you might have a capacity crunch coming from the macro. It's a good, small cells are definitely a good way to segregate your capacity within a tight area. So now that the carriers have the experience of the small cells in the macro, if you want, street level type deployments, I think the next step is definitely going to be to move those types of deployments in building, underground, and so on and so forth.
Yeah, and Mark, any conversation in the telecom industry, we'd be remiss if we didn't talk about 5G and the Internet of Things. So maybe first we can start with 5G. We're a couple years away from a standard, but that's not stopping the vendor and carrier communities from actively going from lab to field trials of some of those underlying technologies. So as we see 5G continue to kind of evolve towards what it'll eventually be standardized as, how is GAP kind of tracking that progress and trying to understand what sort of product needs your clients will have as that takes shape?
So we're definitely keeping close tabs on what's going on in the 5G world. Already just going from 2G to 3G, 4G was a big shift for us in the products that we supplied to our customers and the way that they deployed them. It posed certain threats. So we believe there's probably going to be similar threats going from 4G to 5G, especially that we're hearing a lot about the upper frequencies, above 20 gigahertz, 30 gigahertz. There's definitely a lot of talk about that. I think the shape and especially our involvement in 5G is going to be defined a little bit more in the true applications. Where is it going to be used? Why is it going to be used? What is it going to be used for? Which then feeds into your next topic, which is IoT, I believe. But definitely 28 gigahertz, and we've heard some above 30 gigahertz even recently. That's not going to propagate very far. So if you're planning on deploying that inside a building, you're going to need a lot of antennas. It's not going to bend around corners very well. So definitely we see a lot of opportunity. The issue right now is that we come in, after the standards are set, and once the deployments are decided, the architecture of the deployment, and we're still quite far away from that. I mean, right now it's very much lab testing that's going on. But certainly, again, because we're well positioned in wired and wireless products, there's obviously a lot of wires in a wireless network. We believe that we'll have a good position in 5G for years to come.
Yeah, millimeter wave and those high band frequencies, the propagation with that is so challenging. So I guess to some extent, while we're still way pre-standard, it's good that work has been going on for a while, because there's a lot to solve for with really broadening the use cases around millimeter wave. But like you said, that it is a good segue into IoT. I've heard sort of IoT described as the killer 5G app for years. So I think one area of interest for GAP is aerial vehicles, drones, which are obviously, make a big splash in the consumer industry. But when you look at some of the ways these can be applied to telecom, it's really exciting, the efficiencies that are out there. So how did GAP get interested in UAVs, and what are you guys doing around that?
Well, funny story. It started off as more of a personal interest for my partner and I. We just thought that drones were cool, essentially, and we got ourselves a few drones, and then we realized some of the applications, some of the ways they could be used in our industry. So, the obvious one is tower inspection, which we talked about. We've seen some line of sight applications now that we're working on with customers. We're also working with one of our vendor partners who's developing an RF sensor, so they'll be able to do WCDMA and LTE network quality measurements. So we're seeing, for example, in a stadium deployment or a special event deployment where you're deploying a cow or someone on wheels, multi-beam antennas, you generally have someone who's going to go and walk the venue to verify, make sure that all the beams are in the right places. You don't have any interference, no overlap. So you can now launch a drone with this application that our partner is working on, you'll be able to autonomously choose the waypoints within the stadium or the field that you're in. The drone will go out and fly its mission, collecting data along the way. And although we're already seeing this with some other products, generally it's drive test phones that are literally tie wrapped onto a drone, and you don't get the data until the drone comes back. In the application that our partner is developing, you're going to have real-time measurements back on an iPad that's connected through the downlink of the drone. So you'll be able to collect your measurements and if need be, even align antennas on the fly while the drone is picking up the measurement. So yeah, so that's just one of many other applications that they're working on. So we see a lot of promise for drones. It's definitely LTE and wireless technologies are already a very fast-moving technology. I think drones are moving even faster pace than the wireless technologies today.
Yeah, you know, it is really amazing the efficiency that's gained. I had the opportunity to watch a carrier do their service assurance process at a F1 racetrack, and they used a drone instead of a walk test around this, I think, 3.1 mile loop. And I mean, just the time difference and really the real-time granular optics into how the network's performing. It's just amazing what can be done with it.
Absolutely. And the drone that we're using right now is a DJI Matrice 600, and we're getting close to a 30-minute autonomy. It's capable of putting 6 batteries. So yeah, your 3.2 mile track, certainly in two battery sets, but I believe you can probably do it even in 1 half-hour session and get all your measurements done. Whereas walking that, going to each grandstand, you know, if you're going to be thorough, you're probably going to walk up to multiple spots within the grandstand. So yes, I see incredible efficiencies using aerial vehicles.
So, Mark, what are some of the high priorities for Gap Wireless looking ahead for the rest of 2018 or rest of 2017 and then into the next year?
So we're focusing a lot on, like I said, the small cells. Although it's been a hot topic for many years, I think a lot of the deployments are really starting to proliferate these days and for the upcoming years. So we're keeping on top of the bill of materials and what's involved, the challenges with small cells. I had a discussion with your colleague last year about that. Another hot topic for us definitely is CRAN and CPRI. So we're keeping close tabs on that technology and how that's going to evolve the networks as well.
Yeah, CRAN and small cells, that's quite a value proposition, putting those together and adding a little virtualization. It's amazing how much capacity gain you can get through really getting dynamic spectral efficiency out of the architecture.
Absolutely, yes, and I mean, it means a lot more data that needs to go to each site. So you know, you're replacing a 1 gigabit or maybe a multi-gigabit per second Ethernet throughput pipe to a macro site with multiple, if not tens, of CPRI up to 10 gigs, some 6 gigs, some 10 gigs. So those standards are evolving as well. The speed of the CPRI links. So like I said, everything is evolving at a very fast pace. Just keeping up with it is quite a challenge for us, but it's part of the fun, definitely.
Yeah, and I really think that highlights what you said earlier about how you really don't have a wireless network without a wired network. So CRAN small cluster is a great example of that.
There's so many more kilometers of wires than kilometers of air in a wireless network. So yeah, it's definitely a big part of the wireless networks.
Well, Mark, I really appreciate you taking the time to talk to us about Gap Wireless and some of the trends that you guys are watching and how you're implementing your products to address those.
Well, thank you very much, Sean. It was pleasure was mine.